Hi all, welcome to another video for machine learning course. In this video, we are going to see linear regression in detail. So first we can see the definition. Linear regression is a supervised learning algorithm used for predicting a continuous dependent variable y based on one or more independent variables. Okay, and in linear regression, we are assuming a linear relationship between input and output. That is, input x1, x2, etc. All the independent variables, and the output y is having a linear relationship. So we can see that in detail. We have our dependent variable y and we have many independent variables x1, x2, x3, etc. And we know what is y is a function of all these independent variables, and in linear relationship we are assuming that this f is linear. Okay. For the ease of explanation, in this case we are assuming y is a function of, that is dependent variable, that's a function of only one independent variable. Y is a function of x. In this case, this is known as simple linear regression, and there are many real world scenarios that can be modeled using this. That is, we can say the study time of a student and the marks obtained. As the study time increases, the marks obtained also increases. We know there are many factors affecting these marks other than the study time, that's fine. But here, in this case, we are considering only one independent variable affecting our dependent variable. That is the relation between study time and marks. It can be linear. Another example is the relationship between height and weight of a person. As the height increases, the weight that is supposed to increase. So that also assumes a linear relationship, that is weight and height are linearly related. So using this linear model, we can find out an expression, or we can model our function f. So f is modeled by modeling a line here, that is this line that is used for modeling this, that is known as the line of best fit. We are modeling f using the line of best fit. So actually, what is the line of best fit? It's the line that is closer to most of the points. Okay, it should not be a line passing through most of the points. It is a line closer to most points. That is actually the definition of line of best fit. So machine learning or linear regression is all about mathematics. So we can't simply say we can model f by line of best fit, that is line closer to all the points, most of the points. That we can't simply say. We have to model it, or we have to theoretically or mathematically write or prove it. Okay. So in this case, we are going to assume a simple linear regression, and we can see if we have a straight line like this, you might have studied in your high school classes what is the equation of a straight line. Y is equal to mx plus c, right? So m is the slope of the line and c is the y-intercept. So if that means while we are saying we are modeling f, we are writing a linear equation, we are modeling a line of best fit. That is y is equal to mx plus c. In statistical model, this can be rewritten as beta 1 x plus beta naught, or this can be rewritten as beta naught plus beta 1 x. So this beta naught is the intercept and beta 1 is the slope. According to the straight line equation, beta 1 is the slope and beta 0 is the intercept, and the way of calculating f, that is equal to y is equal to b1 x plus beta 1 x plus beta naught. That's what we are trying to find. We are trying to find beta 1 and beta naught in modeling f. Okay. Now we are going to see a method how to find the line of best fit. Okay. So first assume a linear regression model. Suppose we are taking only 3 points. To make the calculation easier, we are assuming only 3 points. The points are, let the coordinates be 5, 5. Here let the coordinates be 10, 10, and here let it be 10, 5. Okay. So we can call this point as A, B and C. We have 3 points. We can see we can draw many lines through this. This can be line of best fit, right? It's assumed to be a straight line. Okay. And this can be a line of best fit, or this can be a line of best fit, right? So we can draw more number of lines also. We don't know what is the line of best fit. We need to mathematically prove it. Which is the line of best fit that we need to mathematically prove or mathematically calculate. So to mathematically calculate that, we are trying to minimize the error in this. That is the actual value minus the predicted value. or the error denoted by this symbol that we are going to reduce. So we can see the error of point A, B and C with respect to different lines, line 1, line 2 and line 3. We are going to see now. So here you can see, if you take the point A, the coordinates of A are 5 and 5. Suppose we are taking line 1, we can call line 1, this we can call as line 1, this we can call as line 2 and this we can call as line 3. So suppose line 1 is our line of best fit, okay. Suppose line 1 is our line of best fit, the value of A, actual value is 5, the y value, we are calling the actual value is the y and the predicted value is the y hat. You can see if point A actually lies on this line 1, right? You can see point A is actually lying on line 1, 2 and 3. So the actual value and the predicted value, there won't be any difference. So we can write here the actual value minus predicted value of A is 0 for line 1, 2 and 3. So we can check for line B, then the point B, then it will be more clear how to find the error. You can see the point B also lies on the line 1. So there is no difference between the actual value and predicted value. Then now we can see the line 2. If point B is taken, we are taking point B and line 2. So point B and line 2, what is the difference between the y coordinates of point B and line 2? The point B, the y coordinate is 10, but the line 2, at that same point, the y coordinate is actually what? 5. So the actual value minus predicted value, that will be 5. And the line 3, we can call this point as 10, 7.5. So if you are taking the point B and line 3, point B, what is the y coordinate? 10. So line 3, what is the corresponding y coordinate? It's just 7.5. So this error, actually that is the difference in the y coordinates. Difference in y coordinates. That is the error. So you can see point B and line 3. Point B, the y coordinate is 10. The line 3, just below that, the y coordinate is 7.5. So the difference here is actual value minus the predicted value, that is 2.5. Similarly, consider the point C. Point C, the line 1, we are considering the line 1. What is the point C? If you are considering point C and line 1, the actual value is 5 and what is the value in line 1? It is 10. So 5 minus 10, that will be negative 5 here, and point C lies on line 2, so the actual minus predicted, that will be 0. And if you are considering line 3, what is the difference? 5 minus 7.5. So that is equal to negative 2.5. This is the error values of 3 different points based on 3 different lines. Okay. Then after this, after making this table, we are finding out the error of each line separately. So error 1, if you find the sum of squares of error, we are finding sum of squares of error. Okay. We are squaring the error and finding the sum. So line 1, we can see for line 1 the error is 0, 0 and negative 5. So the line 1, the error will be, we are squaring it and taking the sum. So it will be 25. And we can see for line 2, what are the errors? It is 0, 5 and 0. So it is 0 square, 5 square and again 0 square, that is equal to 25. And we can see for line 3, what are the error values? It's 0, 2.5 and negative 2.5. 0 square, 2.5 square plus 2.5 square. So the value will be 12.5. So this, the error we have calculated, and what is the minimum of this error? Minimum of this value is minimum of value, that is given for line 3. That is, error is minimum. The actual minus predicted value, or the error is minimum if you are choosing line 3 as the line of best fit. Okay. So by minimizing the error, we are taking line 3 as the line of best fit, and this algorithm is known as ordinary least square algorithm. ordinary least square algorithm, that is to find the minimum of sum of squared error. Okay. Using that, we can write the y predicted value as beta naught plus beta 1x by getting the coefficients from this. So here you can see we have taken 3 lines, 3 points A, B and C, and we have drawn 3 lines. For example, we have drawn 3 lines. We can draw infinite number of lines. Okay, line 3, line 4, line 5, etc. We can draw as much as we can, and we have made a table to calculate the error. Why we are calculating the error? The minimum error will give the line of best fit. So we have taken 3 lines and 3 points. If a particular point is lying on a particular line, the error value will be 0. You can first write that. If a point is lying on a particular line, the error value will be 0. And for other cases, we can calculate the error value by subtracting, taking the difference between the y coordinates, that is actual minus predicted. So you stick on to actual minus predicted or predicted minus actual. So there can be positive and negative values. Okay. So this is how we find the line of best fit, by finding the minimum value of error. Okay. Now we can see how to find the value of the coefficients, that is how to find the value of beta naught and beta 1 from this. That is, we have already seen the predicted value y is equal to beta naught plus beta 1x in the case of a simple linear regression. And we know we are finding out the minimum of errors, right? Minimum of error 1 plus error 2 plus error, that is error for A, B, C, 3 lines, 3 points, like that it's going. So we can write this in summation notation as we are trying to find out the minimum of sum of all the error squares, that is 1 to n ei. That is the minimum of error we are trying to find out. And we know what is an error. Error is always the actual value minus the predicted value square, right? Error is actual value minus the predicted value square. So this can be written as summation of y minus y hat, that is actual value minus predicted the whole square. And this y prediction, that can be written as minimum of, you can see y predicted value is equal to beta naught plus beta 1x. So I is equal to 1 to n y minus beta naught minus beta 1x the whole square. So you might have studied in your higher secondary +1 and +2 classes, you might have studied how to find the minimum of a function. This is a function. We need to find out beta naught and beta 1 by minimizing this function. How to find the minimum of a function? We have to take the derivatives. You have to differentiate it, find the derivatives, the derivative with respect to beta naught, then equate to 0, find the value of beta naught, then take the derivative with respect to beta 1, equate to 0 and find the value of beta 1. This is how we can find out the coefficients beta naught and beta 1 for simple linear regression. So this is how we find the coefficients beta naught and beta 1 in the case of simple linear regression. That is, we are finding the minimum of sum of error square. Okay, so this is actually squares, sum of error square. We are finding the minimum by taking the derivative. So by taking the derivative, equate it to 0 to find beta naught and beta 1. This is to find beta naught and beta 1, but in the case of simple linear regression. So in the first slide we have seen the linear regression, actually we have a single variable that we have seen y is equal to f of x, and if in the case of multiple linear regression, so that is y is a function of more than one variables, x1, x2, etc. We can see an example of multiple linear regression also. So now we can just have a quick discussion on multiple linear regression. For example, house price prediction. So the price of a house, we can see the price of a house can depend on what all factors. I am just writing an example. Area of the area, that is number of bedrooms. There can be many factors like the number of bedrooms, then actually the location. All this can be a factor that affects the price of a house. So in this case, y can be written as, it's a function of all these variables. If we are writing 3 variables or 4 variables, it can be like this, x3, x4. So what will be y? The y can be written as beta naught plus beta 1x. Okay. Then beta 1 x1, beta 2 x2, beta 3 x3, beta 4 x4, like that it goes on depending on the number of variables. This is what is known as multiple linear regression. Okay, so that's regarding the basics of linear regression. We have to go into more detail, and also we can see some coding part of it that we can have in the coming sessions. Okay, thank you.